So to look at this warm-up, we have the room expenses for two different resorts for a vacation are shown. They want to know when would the cost of the two resorts be equal to each other. So let's come over and make ourselves a chart. Let's do the Blue Water Resort over here, and we'll have the Sea Breeze Resort over here. The first thing we want to do is make sure we understand what's going to happen between each of these two. I know that for 3 nights I can get an $1,100 charge. So we'll go ahead and just start here at 3 nights. Our X values will be our nights. Our Y values will be the price. And it said that this is $1,100 to stay for 3 nights. And then for each additional night, they're going to charge us $112. So that would be $1,212, $1,324, $1,436. If I needed to, I could keep going. $1,548. Every night, what I'm doing is adding $112. As I look at Sea Breeze, it tells me for specific nights 3 through 5. So 3, 4, and 5 nights are given. For 3 nights, it's $1,000. 4 nights, it's $1,100. And 5 nights, $1,210. Now it says here they're available up to 14 nights, and each night is a 10% increase in the price. So I know that because I see the percentage sign, I'm going to have to multiply here, but it's an increase. So what I want to do is take 10% and change it into a decimal, which turns into 0.10. And because of the increase that's going to happen, what I really multiply is 1 plus 0.10. So for Sea Breeze, I'm multiplying everything by 1.1. So I just want to take $1,210, multiply it by 1.1, where I get $1,331. So I keep going. I multiply that by 1.1. I get $1,464.10. And then I multiply that by 1.1. And on night 8, it will cost me $1,610.51. So if we look at our questions, it says, when would the cost of the two resorts be equal to each other? Well, I can see here that is at $1,100. So the price is the same at $1,100, but remember, I'm only getting 3 nights at the Blue Water Resort for that price, and I'm getting 4 nights at the Sea Breeze Resort. So as I go through and we look at more questions, how many nights would Blue Water Resort be a better deal? And how about the Sea Breeze Resort? So to be a better deal, remember, I want to make sure that I'm paying the least amount. Well, I'll be paying the least amount up until night 7 here on the Sea Breeze on this side. So I can see at this point. And if I were to keep going with my values over here on Blue Water, remember I'm adding $112. So that'd be 60. Now it becomes a better deal, again, still to stay at the Sea Breeze. So what I would do to find the answer here is just continue my chart. The better deal is to get more nights for the lower amount of money. So if I were to create an equation here that represents the cost of each resort, well, I know that my Sea Breeze is an exponential function, while my Blue Water Resort is going to be a linear function. And we know this because over here we added $112, and over here we were multiplying by 10%. There was an increase of 10%. Now the only thing that I have to go back and see as I'm getting ready to represent the cost here, whether I stay 0 nights or whether I stay 3 nights at either place, my price will be the same. So as I get ready to write the Blue Water Resort, I just need to take that into account, that it's going to be $112 per night. and that starting value was $1,100. But that's only for X values that are greater than 3, because I get those 3 nights for quote unquote free. And when I come over here to my sea breeze, I know that my starting value, I go back up and look to see how much it started at, was $1,000 for 3 nights. And then I multiplied that by 1.1 every time. But again, remember that is for X values that are greater than 3, because I get those 3 nights, quote unquote, for free at the price that I have. So now let's transition and look at our notes for today. That was the warm-up. We're going to be writing equations of different linear and exponential functions. So we start with slope-intercept form. Hopefully you remember that slope-intercept form are for all linear functions. We have different pieces, and remember this part of the equation, or this equation, is going to be given to us on the formula sheet for our EOC. So all you have to do is click on the page that says formula sheets, and then look for linear functions, and it'll give you this slope-intercept form where y equals mx plus b. M is going to represent the slope. Remember the steepness of the line. This is the constant value that I'm adding each time. And b is going to represent the y-intercept. Now please remember, as I get ready to write the y-intercept as a coordinate pair, my x value will always be 0, and then whatever y value I have, because remember we want this to be on the y-axis, so we don't want to go over any at all. So we just go over 0 and then up or down to whatever the y value is. As we're getting ready to write these different equations, especially if I'm just given what the slope and the y-intercept is, you want to plug the values in. Now, when they say write an equation, the key term there is that we need to leave the x in the problem. If I were to plug something in for x, then that would give me just a value. So, y equals, instead of the m, I take the slope, which is -2, leave the x in the problem, I want it to be an equation, and then my y-intercept is 5. It's a positive 5, so plus 5. Now just remember, when you're watching this video, at any point you can pause, get caught up, rewind if you need to. So please, if you miss something, make sure that you either pause the video or go back and rewatch something. As we look at the second one, the slope is 3/4, so we have y equals my slope of 3/4. That means I'm going to go up 3 and to the right 4, up 3 to the right 4, or I could go down 3 and to the left 4 every single time. But in this case, my y-intercept is -3. Remember, I leave an x in the problem because I want it to be an equation. And because my y-intercept is -3, my equation becomes -3. This part's really simple. When they just tell me what the slope and the y-intercept is, I simply just have to plug into the equation. Now what happens if I'm given a graph? We'll have a couple of different options here of what I can do. First and foremost, I would always start by identifying what my y-intercept is. Now, even though that's the second blank that's given, we can jump ahead and do that. So for number 3, I can tell that my y-intercept is -5. When I get ready to calculate the slope, I told you we have options. The formula for calculating slope is y2 minus y1 over x2 minus x1. And you could take these points and come in and label these. So this would be my x1, y1, x2, y2. Remember, we talked about this was like shoes. You always want a left and a right shoe. You don't want to wear 2 of the same ones. That will hurt your feet. So I always need an x and a y. And I also want my shoes to match. So I need an x1 and a y1. Also, to go with that, whatever I label x2, the y value that goes with it needs to be y2. So I could take these values that I have here and plug them into this equation. So -1 minus -5 over 3 minus 0. This gives me -1. It's like a keep, change problem. So -1 plus 5, which will give me 4. And then 3 minus 0 is 3. So I could calculate my slope to be 4/3. If you just do not want to calculate your slope this way, I can count that I'm going up 1, 2, 3, 4. So again, that was up 4, that's my rise. And then I went to the right, 1, 2, 3, that would be my run. So again, I'm still going to get 4/3. And then as we get ready to plug this in for the equation, it's always y equals mx plus b, so y equals 4/3 x. We want to leave the x in the problem because it is an equation, and my slope, or my y-intercept, is -5, so -5. I want you to pause the video at this point and try number 4 on your own. As you're looking through number 4, hopefully that you recognized your y-intercept is here at +1. I can label my values. Here's x1, y1, x2, y2. So I have -1 minus 1 over 4 minus 0. Again, a keep, change problem. This gives me -2 over 4, and I can reduce -2 over 4 to be -1/2. The line is negative. If I were to put a marble here on the line, it would roll downhill, therefore that would be a negative slope line. Or if I wanted to, I could come in and say I went down 1, 2. So again, that's down 2. And then I went to the right, 1, 2, 3, 4, 5, 6. Clearly, I just counted wrong there. Let's redo that one more time to make sure you're on the right values. I went over 1, 2, 3, 4. So that would be to the right 4. That's where I get my -2/4 that comes out of the problem there. So as I get ready to write my equation, y equals, I'm going to use the reduced version of -1/2. That's my slope, down 1 to the right 2. Leave the x in the problem because we need it to be an equation. And my y-intercept was +1, so +1. So far, everything we've done has been super easy. I've either told you what the y-intercept was, or you could look at the graph and determine what the y-intercept is. If I'm going to be given a table, I need to do 2 things. Again, identify what the slope is by using my formula. Our formula is y2 minus y1 over x2 minus x1. And then we want to find where the y-intercept is. Well, we talked about earlier that the y-intercept is always where x is going to equal 0. So if I have a chart, I simply want to look for where is the x value equal to 0. So let's go through in each of these and first identify where the y-intercept would be. So as I look through the chart, I want to find where does x equal 0, and that's here. So the y value that goes with it for the first example is +1. So if I wanted to identify this, my y-intercept, in this case, is +1. For the second chart, look and see where x equals 0. And in this case, the value that corresponds with it is 3. So the y-intercept would be +3. For the last example, just finding the y-intercept, so where does x equal 0? It's here. And y will equal -1, which makes the y-intercept -1. Now I kind of went out of order according to our steps, because in my opinion it is much easier to identify a y-intercept before I try to identify a slope. Now we talked about the formula, y2 minus y1 over x2 minus x1. So as we get ready to find the slope, this is completely up to you. You can pick any 2 values in the chart that you want. So for the first one, I'm going to pick -2 and -3, and I'm going to pick +1 and +3. I'm going to let -2 be my x1 value and -3 be my y1 value. And then 1 will be my x2, while 3 is my y2. So all I have to do at this point is use my formula. 3 minus -3 divided by 1 minus -2. 3 minus -3 is equal to 6. 1 minus -2 is equal to 3. 6 divided by 3 is a +2. Now as I get ready to create my equation, y equals mx plus b, we just found m, or our slope, to be 2. We leave an x in the equation, and then my y-intercept was +1. So that is how I would build an equation from a chart. Now for the next example, I see that I have some decimals in the problem. Personally, I don't really want to deal with a decimal. I don't really like to do that. So when I pick my two values, I'm going to pick my y-intercept as one of my values, and I'm going to pick 2, 2. Now please understand that it doesn't matter which two values you pick to plug into the slope formula. Any two that you pick are going to work here. I just want to be able to subtract and make things nice and clean. So if this is my x1 and y1 and x2 and y2, well, y2 is 2, y1 is 3, x2 is 2, x1 is 0. So 2 minus 3 gives me -1, while 2 minus 0 gives me 2. So I found that my slope in this case is -1/2. My line will be decreasing or going downhill. So as I get ready to build my equation, y equals my slope, which is -1/2. You leave an x in the equation, and we found earlier that our y-intercept was a +3. Finally, for the last chart, I'm going to use 2 and -7 and 5, 14. Again, it doesn't matter which two values you pick. It's whatever you want to use. So I'm going to let -2 be my x1 and -7 be my y1. 5 will be my x2. 14 will be my y2. So I have 14 minus -7 divided by 5 minus -2. Well, 14 minus -7 is like a keep change problem. So it's 14 plus 7, which gives me 21. And it's like 5 plus a +2. 5 plus 2 gives me 7. Well, 21 divided by 7 is going to give me an answer of 3. So in this problem, my slope is 3. So y equals mx plus b, well, my m, or my slope, is 3. You want to leave an x in the problem, and earlier we found our y-intercept to be -1. Now everything's great as long as my y-intercept is actually in the table. What are we going to do if the y-intercept is not in the table? Well, the first thing we want to do is find the slope. And again, we're going to use our formula, y2 minus y1 over x2 minus x1. Then we're going to take the answer that we have there and plug in for m. We're going to leave two variables here, our y equals x, or y equals whatever we found for m times x plus b. Well, we have an entire chart full of x and y coordinate pairs. So all you have to do is pick a value to plug in for x and y. Make sure, just like a pair of shoes, that we want to have a left and a right, and they want to match. So if I pick 1 for x, that means I have to use 11 for y. So let's see what happens as we follow these specific steps in the chart that's given. I don't specifically tell you which values to pick for your slope. So let's pick 1 and 11 and 3 and 19. So x1, y1, x2, y2, which means I'll have 19 minus 11 divided by 3 minus 1. Give you the answer. Well, 19 minus 11 will give me 8. 3 minus 1 equals 2. 8 divided by 2 gives me a slope of 4. So if I'm following the steps that we were given right up here, we've done number 1. Number 2 says fill in slope into this formula. So I have y equals 2x plus b. Well, now what they want us to do is pick an ordered pair to substitute in for x and y. So in this case, I'm going to use, let's say, 2 and 15. It doesn't matter really what values you pick here. Just pick one that you're going to be happy using. So my y value was 15. I'm going to plug that in here. I have slope times x. Well, my x value was 2. And then plus b. Well, 2 times 2 is 4. So I have 4 plus b. And that's going to equal 15. Well, in order to solve for b, normal algebra, we want to subtract 4 from each side. So my b value is really equal to 11. Because 15 minus 4 is 11. So now that I have my slope and my y-intercept, I plug it into y equals mx plus b. So y equals 4x. Remember, we want to leave the x in the problem. Plus 11. That would be how I create my equation for this. So let's go to the next page. I want you to take a second and try each of these. Remember, the first step that you want to do is look in your x and y coordinate pairs and see if you have a y-intercept. So see if you have an x value of 0. And if you do, then you can just create your equation the way we did earlier. If you don't, then remember you must find the slope first, plug the slope in, pick a value for x and y, and then solve for your b value. So if I were you, I'd hit pause right now on my video and take a chance to do that. Okay, let's look at this example. I notice that I do not have any x values here that are equal to 0. So what I need to do is start by finding the slope. So I'm just going to use 2, 5, and 4, 13 to find my slope. I'll use 2, 5 as my x1, y1, and 4, 13 as my x2, y2. So 13 minus 5 divided by 4 minus 2. Well, 13 minus 5 is 8. And 4 minus 2 is 2. So I can find my slope to be 8 divided by 2, which is 4. And this is great, but because we don't have the y-intercept, I have to use this equation. Instead of an m, I'm going to plug in 4. So y equals 4x plus b. Well, in order to solve for b, I need to take a value to be able to plug in order to find that b value. So I'm just going to go through and I'm going to use 7 and 25. 25 is the y value, so I plug that in. 4 times the x, and the x here was 7. And then plus b. Then we just want to solve algebraically. So 4 times 7 is 28. I have 28 plus b. That's equal to 25. Well, in order to solve for b, remember I subtract 28 from each side. So I get negative 3 is equal to b. Now I have my slope, which we determined earlier was 4, and I have my y-intercept, which is negative 3. So my equation will be y equal 4x, and because that's a negative y-intercept for x minus 3. As I look at my second chart, I want to see if I have any x values that are equal to 0, and I can see that I do. So my y-intercept is actually already identified for me. So all I have to do in this case, since y-intercept is already there, is determine what the slope is. So I'm going to pick two values. I'm going to pick 3 and negative 5 and 6 and negative 14. So 3, negative 5 would be my x1, y1. 6, negative 14 would be my x2, y2. So as we plug this in, I have negative 14 minus negative 5 divided by 6 minus 3. Well, it's a keep, change problem. So negative 14 plus 5 is going to give me a negative 9, while 6 minus 3 gives me a positive 3. Well, negative 9 divided by 3 gives me negative 3. And that's going to be my slope. Remember, I already had my y-intercept, so I just have to plug it into the equation. Y equals, my slope in this case is negative 3, so negative 3x. Remember, a downhill or decreasing line. And my y-intercept is positive 4. Now we're going to evaluate exponential functions. And remember, in an exponential function, my a value is actually the y-intercept. We talked about before, the x value in a y-intercept is always 0, and the y value is what changes. But my b value in this equation, y equals a times b to the x power, is the common ratio. And a common ratio is the number that we multiply by every single time. So I'm just going to have to determine what did I multiply by to get to the next term. Now this would be super simple if I'm just given what the common ratio and the y-intercept is every single time. All I would have to do is plug in. So for this first one, my y-intercept is 3, so that's going to go on the outside of my parentheses. My common ratio is 4, so I'm going to multiply by 4 to the x power. For number 2, my y-intercept is 10, so that's my a value. So y equals 10, and it's a ratio of 2/3, which means I'm multiplying by 2/3 every single time. So 2 divided by 3. And remember, I want to raise this to the x power. X must be an exponent. If I were you, I would beg for a ton of those problems on the test. So let's look at the next 3 examples coming straight from a chart. First thing I want to do, just like it was in a linear function, is determine, is there a y-intercept in my chart? And so if there's a y-intercept, then my x value is 0. Well, I'm very lucky here that my y-intercept is 4. Then I must ask myself, what did I do to 4 to get to 12, and what did I do to 12 to get to 36? And I hope you decided that my ratio here was that I multiplied everything by 3. So once I get to this point, it becomes just like the 2 problems we did. I just have to put it in the equation. My y-intercept was 4. I multiplied everything by 3. I raise it to the x power. As I look at number 4, I want to identify a y-intercept if possible. So x equals 0, boom. It just happens to be that my y-intercept is the same value as it was before. Now I have to determine, what did I do to 4 to get to 10, and what did I do to 10 to get to 25? Well, if you remember correctly, we said that one way of checking an exponential function is by taking your calculator and dividing a2 by a1. So in this case, this would be 10 divided by 4. And then we also want to do a3 divided by a2, which would be 25 divided by 10. And then you just want to take out your calculator. So 10 divided by 4 gives me 2.5. And then as I get ready to do 25 divided by 10, that also gives me 2.5. So I can easily determine here now that my starting value was 4 at my y-intercept. I'm multiplying everything by 2.5, and I raise that to the x power. As I look at number 5, the first thing I want to ask myself is if, is there a y-intercept identified in the chart? Here, again, it is. Still hasn't changed because my x value was 0, my y value is 4. So yet another problem where my y-intercept is 4. Now again, this one's not quite as easy to determine as it was in number 3. So I want to go in and I want to check my values. I'm going to take a2, which in this case was 3, and divide it by a1, which was 4. When I divide that, I get 0.75. Then I want to take a3, which in this case is 2.25, and divide it by a2, which is 3. When I do that, I get 0.75. So now I can come through again and write my formula. My y-intercept is 4. I'm multiplying everything by 0.75, and that must be raised to the x power. Now we've kind of already talked about these in class multiple times. We've just been using the word increasing and decreasing. So another word for increasing is to have exponential growth. And yet another word for decreasing is an exponential decay. And we've done this in class multiple times. We talked about it yesterday, where if I'm increasing, I want to add 1 to the percentage turned into a decimal. And if I'm decreasing, I want to take 1 minus the percentage converted to a decimal. And you have these formulas that are already printed out for you. So all you have to do is revert back and refer to this notes page in order to answer these. Let's get straight into these word problems and see if we can identify different things that will help us. The inaugural attendance of an annual music festival is 150,000. So if we know the word inaugural means the first time, so our first attendance was $150,000. The problem also tells me that the attendance is increasing, so I know it's going to be a 1 plus. We want to go ahead and maybe denote that because it's increasing. And then it also tells me what it's increasing by, 8%. So if I take all this knowledge that I have, the first thing I want to do is change 8% into a decimal. Please be careful. Remember to turn a percent into a decimal, you divide by 100. Most people will put 0.8 here, and that is incorrect. 0.8 equals 80%. So if I take 8 and divide it by 100, I get 0.08. Well, because of this word increases, I know what I really need to do to that is 1 plus 0.08. So what I'm going to be multiplying by every single time here is 1.08. So for part A, if I'm writing the exponential function after t years, that just means I'm plugging a t in for x. I have 150,000, and I'm going to multiply by 1.08. And it said after t years, so I'm raising it to the t power. For part B, it's asking how many people will attend the festival in the 5th year. So I take this exact equation, 150,000, multiply that by 0.08. But now instead of t, what I want to do is raise that to the 5th power. And make sure that you're reading the instructions here because it says to raise the answer to the nearest 1,000. When I plug this into my calculator, I get 220,399. I'm actually going to get a decimal of 0.21152. But I have to remember that my answer says round it to the nearest 1,000. Well, the nearest 1,000 would be right here. The 3 tells the 0 to stay the same. Therefore, my answer would be that the attendance after T years will be 220,000 people. And then for our last word problem, suppose you purchase a stock that is initially valued at $1,000. Well, if it says initially valued, that would be my A value. The value of the stock decreases, so it's going to go down, depreciate, and then it gives me the rate that it decreases, which is 4.5% each year. So when I see the word decreases, I know that I'm going to have to do 1 minus the conversion of the percentage into the decimal. So let's start with that. 4.5% converted into a decimal. If you take 4.5 and you divide by 100, gives you 0.045. Please be careful, 0.45 is going to be equal to 45%, not 4.5%. Because it told me the problem is decreasing, I know that what I'm going to multiply by is going to be 1 minus 0.045. And then it says after X years, so I'm going to leave an X in. My initial value was 1,000. So for part A, I have a couple of options here. I can leave this just like this and still get my problem correct. Or if I want to simplify, I get 1,000 and then 1 minus 0.045 is really going to give me 0.955. So if I want to go ahead and do that subtraction so I don't have to run it every time, that is 100% okay. That's completely up to you. Part B is asking how much the stock will be worth after 10 years. What I'm going to do is replace X with 10. And you can plug this into either one of the two equations. It doesn't matter. So 1 minus 0.045 to the 10th power. Or you could take it and plug in 1,000 times 0.955 to the 10th power. And you can see here as I plug this into Desmos, I'm actually missing one piece here. I had 100 instead of 1,000. So when I plug this in, my answer becomes $631.00 or 0.006329. So really, $630.00. The 6 tells the 1 to go up, so 01. But it says to round it to the nearest dollar. So if I round this to the nearest dollar, my account will have $630 in the account. This is where reading the problem and making sure you're rounding to where it's asking you is going to come in to big play. So at this point, you can stop the video and you can begin working on your homework, which is already posted into Google Classroom. It'll be homework number 13.